Hello and welcome to our lesson on the greenhouse effect and global warming. Okay, so I just want to pause a second to actually talk about why it's called the greenhouse effect. So think about a normal greenhouse. What is its function? Well, the job of a greenhouse is to keep it warm, isn't it? So the glass in the greenhouse allows the sun's heat to go into the greenhouse, but then it traps some of the sun's heat. And so it's a little bit warmer in the greenhouse. If you go into that greenhouse, it will feel warmer than the outside because it's trapped some of the sun's heat energy. And that's what it does, and that means you can grow your plants. And this is directly connected to the idea of the greenhouse effect. It's this idea that it allows the heat in, but then it traps some of it to keep things warmer. I just want to draw your attention to the greenhouse gases. We often talk about carbon dioxide, but there are other greenhouse gases, so gases that act like the greenhouse in the atmosphere. So all of these gases would allow heat energy in from the sun, but also then act to trap some of the heat energy closer to the earth. So it's not just carbon dioxide, methane, ozone, which is O3, nitrous oxides, and even water vapor. So when you're answering the exam question, just be really aware that they might talk about the others as well. But if you're answering greenhouse gases, you really do need to be specific. So if name some, if you're not sure, you get the mark for just saying greenhouse gases. Okay, so the greenhouse effect is a natural process, okay, and it's been around since we've had an atmosphere. It's not man-made. So what actually happens in the natural greenhouse effect? Well, first of all, short-wave radiation from the sun passes through the atmospheric gases without being absorbed. So this is this bit here. In comes the the radiation, infrared radiation from the sun, and it goes through the atmosphere to the earth. It's not being absorbed, it's going straight through. And this is shortwave radiation such as UV, so ultraviolet, visible light and infrared. So infrared radiation, which is the stuff that causes heat. Long wave radiation from the earth is absorbed by the atmospheric gases. So then we've got long wave radiation coming off the earth. So the earth is warmed, and then you've got long wave radiation coming off the earth, and it is absorbed by the atmospheric gases. So it goes into the atmosphere. And that is stuff like the longer or the far infrared radiation. And so the Earth's temperature increases. So what I would like to point out is you are looking to mention the shortwave radiation passing through and the long wave radiation being absorbed. And it's not, where is that long wave radiation coming from? It's coming from the Earth itself. So the Earth is warm and it's releasing that long wave radiation. Global warming, literally the globe, which is the Earth, becoming warmer, is caused by the greenhouse effect. They're not the same thing. So you've got to be really careful in your answers that you are making that distinction. The greenhouse effect is this heat being absorbed by the atmosphere. That means the Earth gets warmer, and that is global warming. Okay, so greenhouse effect causes global warming. Now, the natural greenhouse effect is healthy and good. We need the Earth to be warm. Without the greenhouse effect, the Earth would be too cold to support life. Now, what we have done is through pollution, added more of these greenhouse gases into the atmosphere, causing the Earth to absorb even more long wave radiation and making the Earth hotter than it would be naturally. So that is the human effect. Now at this point, I want to just pause and think about, is there any other reason or any other causes for global warming? Well, absolutely, yes, there is. Global warming comes, so the Earth gets warmer because more of the radiation is being absorbed. So more radiation has been absorbed because there are more greenhouse gases in the atmosphere. But those greenhouse gases don't necessarily have to come from human activity, from pollution. So here's a really good example. volcanic activity. We know that if you go back to the story of the evolution of the atmosphere, we know volcanoes kick out humongous amounts of greenhouse gases, the ammonia, the methane, the carbon dioxide, the water vapor. And if that's going into the atmosphere, it's going to make a huge amount of difference. It's a phenomenal amount of greenhouse gases getting pumped up every time the volcanic eruption. So if you get a time period when there's quite a lot of volcanic activity, it's going to make a difference. So another reason is coming off Earth is looking at the sun itself. Now the sun obviously is basically a great big nuclear reactor, and sometimes it's more active than others. So sometimes the sun literally is hotter than other times, and so you get obviously if it's hotter, it's going to be releasing more infrared radiation, and therefore the Earth will be warmer. And sometimes it's not releasing as much infrared radiation, so the Earth will be cooler, and that would change the weather systems on Earth, and it would change the climate where we're living. It would be colder, it would be warmer. So the sun plays a part in global warming, well, in the greenhouse effect, in global warming, and in climate change. The climate change is the consequences of global warming, where the climate, the weather where we live changes because of global warming. Geographers out there will be aware of Milankovitch. Milankovitch was a scientist who understood the orbit of the Earth, and recognizing that sometimes the Earth is closer to the sun and therefore it would be naturally warmer, and sometimes the Earth is further away from the sun and so it would be naturally cooler. So there are things going on that are out of our control. They've got nothing to do with humans, that may be influencing the amount of radiation hitting Earth and the amount of infrared radiation being absorbed by the atmosphere. And that will affect the greenhouse effect, and that will affect global warming, and that would affect our climate. So then let's look at ways that human activity may be making it worse. So this is what's called anthropogenic effects. Okay, so anthropogenic is human activity. It's a very posh word, but it just means humans. So what are humans doing potentially that are making things worse? Well, we know that burning fossil fuels and making all these things that we make in factories are causing pollution. We're releasing a lot of these gases into the atmosphere, carbon dioxide, nitrous oxides, all adding to the greenhouse effect, which is causing global warming. Another way we might be making it worse is deforestation. So what absorbs carbon dioxide from the atmosphere? Well, trees. So if we chop down trees, they're not absorbing the carbon dioxide, they're not photosynthesizing, and so the carbon dioxide that was in the atmosphere is not leaving the atmosphere either. So it's a bit of a double whammy, really. Things like farming. Farming on an industrial scale can be a problem. We're clearing out a lot of land, so deforestation, destroying a lot of habitats, and of course every single one of those tractors and the combine harvesters have massive pollution problems there because they're burning fossil fuels. And of course, burning fossil fuels again. Here we've got a factory, and of course cars burning the petrol, the diesel, not just releasing carbon dioxide, but releasing things like nitrous oxides and sulfur oxides, which are causing problems as well. Things like methane from landfill sites is another greenhouse gas. So are we helping? Absolutely not. Are we the only cause? Absolutely not. And you need to be able to kind of talk about both sides. What are the natural ways that the Earth might increase the temperature, and what are the anthropogenic reasons why global warming might be occurring? So here's what we're talking about then, guys. The natural greenhouse effect is a good thing. Without it, the Earth would be too cold. The human enhanced greenhouse effect, that's us adding the greenhouse gases into the atmosphere and making, it's a bit like wearing a warm winter coat on a hot summer's day. You're going to get too warm because you're keeping too much heat close to the body, and the enhanced greenhouse effect is keeping too much of that heat in the atmosphere, and it's keeping the Earth too warm, and I think global warming is occurring. It is likely that you're going to be met with some rather ugly looking graphs on our paper 2 question, looking at the relationships between various things. What I would point out here, guys, is you need to be really careful with the data you're looking at. So for this one here, the first one, I've got dates along the x-axis. I've got degrees temperature in Fahrenheit here, though that would never happen in an exam. And I've got carbon dioxide parts per million here. And of course, then I've got 2 lines here. I've got a global temperature and I've got carbon dioxide in red. Now, obviously, you would have a black and white on an exam, so it would be relatively clear. But you might be asked, you know, what's the relationship between global temperature and carbon dioxide? And you might say that as the global temperature increases, the carbon dioxide level increases. But you'll notice it's not a perfect match. So you could be asked, you know, is it a good correlation? And you'd say, well, they are both increasing, but there are areas like here where the temperature has gone down, but the carbon dioxide levels have gone up. Whereas here, the carbon dioxide levels have gone up a little bit, but the global temperature has risen massively. And you would be quoting that date, 1940. Yeah, there might be another reason for that. Maybe there was a volcanic eruption then. This one here is talking about thousands of years before today. So you've got to be careful with the thousands of years, or look at this one here, age before present. So we're talking a long time ago. So of course, humans did not become industrialized until the 1800s. So you're talking over here. This has got nothing to do with humans. Over here, it's got nothing to do with humans because we weren't around at that point. We definitely weren't industrialized at that point. So just be really careful at looking at the graphs and looking at the relationships between the things that they are asking you about. Okay, that's the end of this lesson, guys. I'll see you next time.